Hi guys, welcome to today's class. Like I said, we are still in the process of solving the problem. So I've gone through different stages and I believe you already have answers to my questions. If you don't, I will collect them at the end of the class. And also you have carried out data collection effectively. You've gone through the stages of observing, you have properly observed. Remember, in science we do what we call careful observation. When you're walking down the road, there are so many things that are happening around you. Yes, you are aware of them, you're actually seeing some things. But there's a difference when you actually pay attention to what you are seeing. So you're not just merely observing, you are doing what you call careful observation. And in science, we do careful observation. So not just observation, careful observation. Now you have measured, if you need to take probably the number of people affected by the problem. I hope you have done that and you have done correct sampling. And of course, you are properly organized. Now, we're going to the next stage. Now, this stage is a critical and a very important stage of the scientific method. And the stage is called hypothesizing. Now, in hypothesizing, from the name hypothesizing, it just simply means making hypotheses. So, the word is big, right? But actually, the meaning is not that bogus. Just making hypotheses. Now, hypothesis could look also quite complex. Now, what is an hypothesis? An hypothesis is a statement that explains observations and also describes ways in which it can be tested. So, you have done a lot of observation. Now, before I proceed, I would like to say this. You only make an hypothesis after you have done careful observation and you have collected sufficient data. That is, you don't just do an haphazard job and just come out and say, oh, this is what I believe is the reason. Not more like what the women in your neighborhood do. You see somebody having some funny illness and they start saying, oh, it's because right, if you touch his head, the guy will behave well, or because he slept on the floor. Because just some funny reason we they bring. In science, we don't do that. You don't just come out and say what you just believe. What you feel should be the reason. Now, well, we call it toxic. That's what we call it. Informally, we say that's toxic. So you don't move toxic in science. You move fact, because we deal with factual information. So you only make hypotheses after you have done careful observation and you have collected sufficient data. That is, you make hypotheses from a position of authority per se. That is, you have done what needs to be done. That is when you make an hypothesis. That's why you say, oh, having seen all what I've observed, having collected all the sufficient data, what I'm saying, I believe that this is what explains this observation. This is why there's a disease outbreak. This is why you are suffering from this illness. This is why children in certain countries have low nutritional level. This is the reason why, oh, this area is prone to these infections. Or this is the reason why we have these crops dying in their numbers in this region of the country. So you make those statements after you have done what needs to be done. But the truth is, hypotheses can go through different stages. It can be refined, it can be revised, or it can even be discarded. Yeah, that's true. It can even be discarded as new scientific evidence comes up. But notwithstanding is also an important stage, because this is more like the stage that it tells you, should I move on or should I move on to the next? It's more like a midpoint between, okay, collecting data or data collection stage and also the main actually putting those data to use. So that's where like hypothesis serves as a bridge. So that's why it's a critical stage, because at hypothesis, you will know probably, oh, I don't have sufficient information, let me go back and gather more. Or probably, oh, this statement doesn't really explain what I'm observing, doesn't explain what I'm saying, let me do more. So it's more like, it's the stage of check and balance. That's what I'm trying to say. The hypothesis is more like the stage of you are doing a kind of check and balance on what you have done so far. So it's very important. Now, in science, when you make an hypothesis, now, I've told you it can be revised, it can be refined, and it can also be discarded as new scientific evidence comes up. But you see, how do you know that, oh, I need to refine this, I need to revise this, I need to probably discard this. Well, we don't always like that, but the truth is, at some point in time, you could just say what is not right, and you always have to discard it. So, like I said, the process of science is meticulous, so you don't just rush it. Just follow the process, because if you do follow the process, the result you get at the end of the day is something which you love. You've read about scientists like Albert Einstein, you've read about Lord Rutherford, you've read about those popular scientists, you've read about Marie and Pierre Curie. Today we celebrate them in the field of science. So that's because they follow the process. If they didn't, you won't be hearing about such names today. They follow the process and they got beautiful results which still find applications in today's world. So you have to follow the process. And that is why from the stage of hypothesis, you need to test it out. So the next stage after hypothesizing, which is the next stage in the scientific method, is experimenting. Now, it's in this stage of experimenting that you test out what you have said, right? And remember I told you initially that hypothesis is a statement that explains observation and also describe ways in which can be tested. So more like you're doing two things in the stage of hypothesis, which I previously mentioned. You are also making a statement explaining, you're also telling how you can test out what you said. And the process of testing out hypothesis is through experimenting. So experimenting is very important due to two major reasons. Experimenting tests out the process of hypothesis. And number two is that experimenting tests out the prediction which you have made in your hypothesis. So for instance, if you say that, okay, the process of relieving pain is by administering aspirin. So an experiment will be carried out to administer it to see whether what you are saying is true. And if you say, okay, in the drug administration, if you want it to be very effective, do it intravenously, that is directly into your blood vessels. An experiment could be that we will test it out. Probably we give some set of people, we give them orally, some set of people we give them intravenously, some set of people we give them subcutaneously, that is just beneath the skin. So we test it out. We have different groups of people taking this aspirin different ways, different modes of routes of administration. So now we are testing out the process, because in your hypothesis you said that, oh, the reason why these people are feeling pain is because they probably inflammatory reactions and the rest, and you are saying that that's what you observe, and one way of solving that is by giving them aspirin. You not only said that, you said the aspirin should be given intravenously. So that means you are describing the process in which the aspirin should come in. So we could test it out and give them different ways. So now, if at the end of the day we see that, oh, people who took it intravenously elicited more relief, that means we have proved that aspect where you said, when we were talking about the process that give it intravenously. Now, if the next stage which you mentioned your hypothesis, probably you said that if you give it to people, a number of 50, that after like 3 or 4 to 5 days, about half of that population should have completely gotten relief. So the next thing is that for the next 4 to 5 days, we'll be looking at, okay, half of the population had relief, as you said. And if that happened, that means through the process of experimentation, we have tested out both your process and the prediction of hypothesis. That means we can veritably say, oh, this statement correctly explains the observation. So now, if, let's say, it doesn't work out that way, probably your prediction was wrong, they didn't even have relief, or probably it took longer time to have relief, or probably intravenously didn't work, probably subcutaneously worked, that means that your hypothesis is already completely wrong. So you as a scientist will go back to the drawing board and refine. You could, or even discard the statement. You could refine it, you could revise it, or probably you could just discard it from the word go and start all over again. Like I said, hypothesis is an important and a critical stage in the scientific method, and also that is stage that serves as check and balance. So it tells you whether to proceed or not to proceed. And when I mean proceed, that is moving from the data collection stage to the next stage, which is applying all those, putting into practical use what you have discovered. And the way you test out hypothesis is through experimenting. That's all now, guys. So I'll be seeing you in the next class, in the next video, and we should have solved that problem.